Hey everyone. In today's video, we're going to be taking a look at OSPF route types and look at the path selection of OSPF. And specifically, we're going to try to determine if the Cisco implementation of OSPF does path selection the way that it says in the RFC. Um, so this is going to be a little bit of an unscripted video. I'm just going to I've been doing a lab to verify that this is going to work, and you're going to watch me, you know, take a look, and we'll also learn how it's supposed to be. So the first thing I want to do is just go over what we're actually supposed to be seeing, and that's the first routes are O routes. Those are the intra-area routes. So those are routes within your area. Then that is preferred over OIA, which are inter-area routes, so routes coming from outside the area. Then we have E1, which are external type 1. I put an M there, but that's clearly not that. It should be NSSA. So then we have NSSA type 1. And those two will be preferred over E2 and N2. So this is the top to the bottom. The O routes are supposed to be the most preferred routes, and the E2, N2 routes are supposed to be the least preferred routes. So I have a lab set up here. We're going to go through configuring and taking a look at, how this works. So the first thing I just wanted to point out is, well, actually that doesn't matter yet. What we're going to do is we're first going to take a look at R4. We'll create a loopback on R4, and we'll leave it in area 0, because we have basically this whole network here is going to be area 0. And what we're going to do is we're going to have a loopback in the area, and we'll take a look at R2 as an O route versus R5. We'll create a loopback here, but it'll be in area 5. So that should come into here as an OIA route, and we'll see which one's preferred. It should be the O route. So let's take a look. Let's go to R4, conf D. We'll do int loop, we'll call it 45, why not? IP address, we'll say it's 45.0.0.4. Actually, we'll say 0.0.1. That's 0. IP OSPF 1, area 0. End. So on R2, we can take a look, show IP route OSPF. And we already have the route here, 45.0.0.1. And actually show IP route. Why does it have it as a host route? 45.0.0.1/32. Did I put it in as a /32? No, I didn't, but that's OSPF. Okay. That's OSPF assigning the network type loopback to the network, which is fine. On R5, we'll just configure the same thing. So conf T, router OSPF, interface, we'll call this loopback 45 as well. IP address 45.0.0.1. IP OSPF 1. Area, this time we'll do area 5. So now if we do show IP route, okay, we see the directly connected one. We see the directly connected. Let's head over to R2. All right, so we still see it preferring the O route. Let's just do a show IP OSPF database. And we could see we're getting the summary route, so it is learning it from an inter-area, but it's still preferring the O route. Okay, so perfect. We verified that O is preferred over OIA, which we kind of already knew, But let's go ahead and take away the O route. So let's go to R4. Actually, let's just get rid of it. No int loop 45. So now what let's do is let's go to R1. That's fine. It's one hop away. Let's create a loopback with that same exact IP address. And this time what we're going to do is we're going to do some redistribution into OSPF, and we'll do it as an E1 route. I realized that was actually kind of... Let's write that over here. We'll have it come in as an E1 route. And we'll see who R2 prefers. It should be the route from R5, but conft int loopback. I guess I'm stuck with 45 now, but that's fine. Forgot an octet. That's fine. And I don't think, did I do a network command on this? Section router OSPF. Redistribute connected subnets is already there. So we should be doing redistribution. So let's head over to R2 and take a look at the show IP OSPF database. Make sure we're learning that. So we are learning it as a type 5 and we're learning it as a type 3. We should be preferring the type 3. Show IP route 45001. And sure enough, we're learning it from R5 still. Okay, so far we've confirmed, and I guess I'll just keep track to double check, what we've actually confirmed. We've confirmed that O is preferred over OIA, which is confirmed over E1. All right, now this will be an interesting one. So let's take R7, which is here, and I actually have. We'll need to do a little bit of. This link here is actually off, but what I have here is between 4, 6, and 7. I have an NSSA. So we'll create a loopback of R7, and we'll have it go in as an E1 route. So we'll see, not an E1, an N1 route. And we'll see what's preferred more, the E1 or the N1 route. And I'm sorry I'm slow today with this, but that's okay. So what we'll also have to do is let's get rid of this loopback on R5, because we've already confirmed that's more preferred than the E1 route. So let's go conft no int loopback 45. All right. So let's go to R7. Okay. And OSPF, all I have is the NSSA configured. So router, OSPF1, redistribute connected subnets. Okay. So let's just go to R6 and confirm show IP route OSPF. So I could see an N2. And let's head over to R2. And now we're learning it from 1, which makes sense. That's our E1 route. It is equal distance, though. So why don't we actually head over to R4? Because R4 should have the same metric. So let's just pick. So that was probably a bad example because the metrics are different, but we want to make sure that we're actually doing it. So here's we're basically, everything is the same, so we're basically turning this into a hop count. That's 1 2 1 2. The metric on every link is 1 right now. So let's go to R4 and let's show IP route OSPF. Let's take a look. Now it looks like we are preferring the N2 route here. That's interesting. So let's show IP route 45000, and let's do a show IP OSPF database. Interesting. So we're learning the type 5 from 1, and we're learning it. Oh, no, this is area 47. Let's go to area 0. Yep. Okay. Area 0, area 47. So our type 5 LSAs. So here's the LSA that we're creating to do the type 7 to type 5 translation. But we're learning that there, and we're learning it here. It looks like N2 is actually being preferred over N1. Very interesting. We can confirm. Let's do a show IP OSPF. Database NSSA external for 45000. Metric type is 2. Our metric is 20. Okay. And then for the type 5, I mean, it should be this. Oh, you know what? This is a type 2. Huh. So I forgot to do it as a type 1. That's my fault. So I need to redo this again. So here's what you get with an unscripted lab. This is actually a type 2, and this is a type 2. But what we've confirmed is that OSPF actually confirms the N2 over an E2. So that's interesting. Let's go ahead and change that to an E1 and an N1. So I will, in this case, actually do an E1 and an N1. And let's see how it goes. So conf t router OSPF1 redistribute connected subnet metric type is going to be 1. And on R1, we're going to do the same thing. Conf router OSPF1 redistribute connected subnets metric type is 1. Okay, so now on R4, let's do the show IP route and let's see if our metric changed. So now we're learning it as an ON1. Interesting. Show IP OSPF database. So let's do a show NSSA external. The metric type 1, it shows the metric is 20. Okay. Let's do an external for 45000. Metric 20, metric type 1. So yeah, it looks like OSPF prefers the N routes over the E routes. So we need to make interesting. N1 over E1. And now let's confirm. So we know it prefers N1 over E1. Now let's see if it actually prefers E1 over N2. It should. In order to do this, we'll go to 7, and we will router OSPF1, no redistribute connected. I'll just make sure. Sometimes Okay, so all right, conf c. Let's go to R4, make sure that we're actually learning. Show IP route. Okay, now we're learning it from an E1. Okay. We just connected subnets N2. We're not going to change the metric type here. So let's see what happens when we go to R4. Okay, it still prefers the E1, which is what we would think would happen. Let's do a show IP OSPF database just to confirm we have that route. We have the type 5 and the type 7. So there you go. And now to show you why this is important, which I guess I probably should have done it at the beginning, is if we go to R2, so we know that an E1 is preferred over an N2. If we go to which one? I don't. R6 is not a good example because it's in an NSSA. I'm trying to think of a spot where this is 1-2 hops. Basically, the point that I'm trying to make is it doesn't matter what your metrics are or how good they are. And actually, I could prove this. I don't have to do any major redesign. Conf t router OSPF1. Let's do redistribute connected subnets. Metric type is 1, and the metric I'll set to like 100, which is much worse than the metric that we're learning over here. So to explain what I'm doing. Okay. And let me clear some more of this stuff just so it looks a little bit cleaner. Okay. All right. So, R7. We're doing an N2 route here. The metric of the route is going to be 20. It's going to hop here, here, to R2. And we know from the recursion that the forward metric will be 3. But the metric of the route itself will be 20. I just redistributed R1 into OSPF over to R2 with a metric of 100. But this route is an E1 route. And we prefer E1 over N2. So, if we go to R2 and we show IP route, we can see the metric is 101, but it's a type EX external 1. So the point I want to make here is that the way OSPF path preference works with these routes is it doesn't matter if the route is worse metric-wise. OSPF is always going to go in this order. So you could have your intra-area route have a metric of like 3,000 and maybe having an E1 with a metric of 500 and an E2 with a metric of 1. Clearly the E2 route has the best metric, but the router's never going to choose this route. It will always choose the O route. So it looks at this before it even looks at the metric, is the point I'm trying to make. So you can, don't waste time trying to traffic engineer, trying to do metric changing on links to try to get OSPF to prefer this route here over this route. It's never going to happen because this is an E1 route. So that's why this is important. And it is also important for us to know that, the N1 route is preferred over E1 and N2 is preferred over E2. Everything else kind of went the way that we thought it would, but that is something interesting about Cisco's implementation. So I hope you guys found this video interesting. I hope you found it informative. I certainly got a little bit out of it. I didn't, every piece of literature I had read was saying that the E1 is preferred over the N1 and the E2 preferred over the N2, but everything else pretty much went the way I thought it would. So thanks for watching. And actually, before I end this video, what I found, I had hit pause and then I had come back to it. OSPF has a new RFC, which now makes the old RFC, which was... So the old RFC was 1587, which had the OSPF NSSA option, and this specified the order. The new RFC is 1301, and you can see it obsoletes the old one. In this RFC, let me pause the video again, actually, to not waste more of your time. So, not to make this video much longer, but in this section of RFC 3101, we can see the preferences as follows. So you could see here, intra-area, and inter are always preferred over external. Type 1 external are always preferred over type 2, which makes sense, which we saw. Then we see that we have type 7 LSA. I'll just jump down to here. We have a new preference where type 7 with the P bit set is preferred over type 5. So this is the new RFC. It's 3101. I do suggest you read it. But the point being is now we know for certain, and I probably should have done more reading before I did this video, but that's okay. Apparently all the books are obsolete. When did this RFC come out? Actually, this is another good thing to know as I ramble on more in this video. 2003. So I don't know why all the books are so obsolete on this, but anyway, we know it's OIA, N1, E1, N2, E2. And the RFC again is 3101. All right, that's it for this video. Thanks for watching. Hope to catch you on the next one.